Hi everyone. So here we have the last question of our series, June 23, Pure Paper 1. Right? So let's get started. This question is very important and has many marks here. If you count, like 5 plus 2 is 7, 8, 10, 13. Total 13 marks. That includes differentiation, the first part, and then we have some understanding of numerical method to be tested over here. Okay, let's continue. So if you see, we have a function given, an equation given, and we have to find f dash x. Actually, we have to show it in this form. Fine, you can easily understand that we are going to be using the quotient rule. So I'm ready with the formula of quotient rule. So this is what we use for quotient rule, right? So let's continue. For f dash x, let's quickly differentiate that. So we will keep the same. So square root of e to 3x minus 2, and we are going to be differentiating the top thing. And if you see the top thing, it is the product rule there, isn't it? So it's a very nice question. So say for example, I'm going to be differentiating e to power x first plus 7 e to power x, and if we differentiate x, we're going to be getting 1. Okay, so this is done. Minus, now we're going to be keeping the top number the same, 7x e to power x, and differentiating the bottom one. So if you have to differentiate root x, what we get? Half, I mean, what type of half is this? Just give me a sec. Half x to the power minus 1, minus half, I mean, that can be written as half root x, right? So if it is like our denominator is root, so we will be getting half, can I say root e to the power 3x minus 2? Because it's not x, so we're going to be differentiating back. So it would be 3 e to power 3x. So this is what we have got. And now whole over your v squared. So if we square the square root, we're going to be getting, I'm just writing 1. I mean, what I'm doing, instead of drawing a big whole bottom, 1 over e to power 3x minus 2. Hope that makes sense. Either you write it like this or like that. Okay, let's do one thing. First, I'm writing it like this only, and then from next step, I'll be just compressing it down. So now what we can do, let's take 7. Okay, let's do one thing. Remove the bottom. I mean, remove the denominator, this denominator. So for that, we are going to be multiplying and dividing by 2 root e to the power x minus 2. So what we are doing, we are going to be multiplying by 2 root e to the power 3x minus 2 and dividing by 2 root e to the power 3x minus 2, and we already have e to the power 3x minus 2 at the bottom. Okay, now what we're going to be doing, just copying the top thing. So I'm going to copy the top thing. Okay, so this is what I'm going to write over there. Let me just make it a bit smaller. Okay, perfect. It was root, right? Okay, now when we expand, if we multiply this, so the root is going to be removed, correct? And if we multiply it to that particular part, we're going to be getting it cancelled. So we will be having over here 2 e to the power 3x minus 2, 7x e to the power x plus 7 e to the power x minus 7x e to the power x and 3 e to the power x. This is cancelled. And whole over, we have got 2 e to the power 3x minus 2. Okay, nice. Now what we're going to do, we are going to be taking 7 e to the power x common because it's here. it's there and it's there as well. So if we take 7e to the power x common, we're going to be getting 2, I'm just expanding it, 2e to the power 3x, this is what I'm expanding here, minus 4 in a bracket. And if we have taken 7e to the power x out, so it will be x plus 1 minus 3x e to power x, correct? And 3/2 is there, e to the power 3x minus 2 to the power 3/2. Okay, we are about to reach to the destination, e to the power 3x. Okay, let's expand that. It's going to be 2e to power 3x, 2x e to the power 3x plus 2e to the power 3x minus 4x minus 4 minus 3x e to the power 3x over 2e to the power 3x minus 2, 3/2. Okay, if we solve it more, so this can be simplified. So we're going to be getting 7e to the power x, to just copy that down quickly, and here we will get minus x e to the power 3x plus 2e to the power 3x minus 4x minus 4. Okay, I think we are about to reach the final step. 7e to the power x over 2e to the power 3x minus 2, 3/2. And here, if we take e to the power 3x common, we're going to be ending up with 2 minus x minus 4x minus 4. Okay, let's check what exactly we were supposed to prove. Over here, there is the question. So 7x, okay. Shall I take the screenshot and add it over there? Because, okay. So there we go. This is what we were supposed to prove. I think we've reached 7x e to the power x over 2. Yeah, so this part is correct. And then e to the power 3x, 2 minus x minus 4x. That means a is minus 4 and b is minus 4 as well, right? Now let me move this there. So we have proved the first thing. Now we are going to be switching to the next part here. The next part, what it shows, let me zoom it. Part B, we've got 5 marks, right? Part B is saying, hence show the coordinates of the turning points. For the turning point, our f dash x is 0, isn't it? Okay, so what we have to do, just read it out. We have to show that the turning point, this is the turning point. Okay, so if we make f dash x to be 0, we're going to be getting 7 e to the power x e to the power 3x 2 minus x. Our equation was minus 4a, not a, minus 4x minus 4 over 2 e to the power 3x minus 2, 3/2 equals 0. Okay, and we have to prove this. X the subject. So we're going to be getting 7 e to the power x e to the power 3x 2 minus x minus 4x minus 4. That is equal to 0. So do you feel like my x looks like n? I'm just trying to make it better, though it may be. Okay. Now we just have to make x the subject, right? So from here we can say e to power 3x 2 minus x minus 4x minus 4 equals 0. We have to expand this. It would be 2 e to power 3x minus x e to power 3x minus 4x minus 4 equals 0. If we take x common, we have to make x the subject. if you take x common and move it around that side, so we're going to be getting x e to power 3x plus 4, that is equal to 2 e to power 3x minus 4. Just divide by this, so you're going to be getting x to be 2 e to power 3x minus 4 over e to power 3x plus 4. And this is what we were supposed to show. Correct? Okay, that's great. Now let's move it. Yeah, it's going to be taking some more time for discussion because it's of 13 marks. I'm just quickly moving it down there. Okay. Oh, it's overlapping. Never mind. I'm moving it here, probably on the next page. And okay, you've understood this, so that is not a problem, but I will be needing this page after some time, so I'm just adding it here. Okay, that's nice. Now what we have to do, B part is done. The equation has two positive roots, alpha and beta, where beta is greater than alpha, and we have to use iteration formula in attempt to find. Diagram 1 shows a plot of the part of the curve with equation this and the part of the line with equation this. Using the diagram 1 on page 42, draw a staircase diagram. Okay, we have to draw a staircase diagram. Let's get started. So for the staircase diagram, what we're going to do, here we can just at the top of point 1, you're going to be drawing the staircase, and over here you will draw the staircase with an arrowheads like this, right? So yeah, this is done. Now it was for 1 mark only. Use iteration formula for x equals 1 to find the value of x2 and beta for 3 decimal places. Okay, for this one, let's quickly go to discuss D part. So for D part, x2, this is xn given to us. So we have to find x2, right? Okay, D part we are solving here. x2 is going to be 2 e to the power 3 x1 minus 4 over e to the power 3x1 plus 4. That will give us 2 e to the power 3 because the value of x1 is 1 minus 4 over e to the power 3 plus 4. If you use your calculator to solve, you're going to be getting, I think I have solved and pasted the value. So I have got 1.50177 something. Okay. So 1.50177 something. So for 3 decimal places, we're going to be getting 1.502. Okay. And now for the value of beta, you just have to use your calculator. Use your calculator for values and see what gives you the approximately like similar value. So I'm just quickly showing you. You just have to use a calculator. I have the data over here. So if you see, like these are quite similar values we are getting. So we have to take 3 decimal places. Can we say 1.968? 1.968. So the value of beta is going to be, this is x2. The value of beta will be 1.968. Correct. Okay, now after this we have to do the last question using this. Okay, so for E part, let's quickly do E part. So we have the equation given and the equation of the line given. So can we say our function hx is 2 e to the power 3x minus 4 over e to power 3x plus 4 minus x. Now let's find h 0.04. Okay, if I say 0.432 0.20. Okay, so can we say that we have to find the values for 0.4315 and 0.4325? So let's find the values. Use your calculator, please, and tell me if you're getting 0.4325, if you're getting positive and negative. So I think I have added the calculation for this as well. Okay, yeah, so over here when we are solving it for like if you see, this is for 0.4315, that gives us minus 2.9746 9159 times 10 to the power of minus 4. You can also write in decimals. So it is negative, and the other one is a positive. So we definitely have a root, and we definitely are getting a root over there. So yes, we can say, because there is a change of sign, so we're going to be getting a root, and f dash x is continuous. So alpha equals 0.432 to 3 decimal places is a root. Yeah, that's correct. Perfect. I hope it makes sense. It's quite long, but yeah, it was actually 13 marks. A lot of detail over here. Hope you're able to understand the thing. You might need to go through once again, maybe. Okay, so we are done over here. What should we start next? I mean, let's have a quick plan for the next thing. I think we should go with paper 2 and then paper 3 and then switching to co-pure. Would you suggest? Okay, so just share your thoughts or whatever the plan we should include through comment. Bye-bye. Take care.